Oh, hey guys. Today we're going to look at the graphs of tangent and cotangent. Previously, you guys have become experts at graphing sine and cosine. So now we're going to take a look at the other two trig functions, tangent and cotangent. Someone's a drunk. Don't you hate it when gravity's axis just shifts to 90 degrees? Hang on, let's fix this. All right, that's much better.
What's up?
Mr. Mack.
All right, Mr. Simmons. Today
All right.
we're doing tangent and cotangent.
Parent graphs.
Parent graphs. All right, so we know, talked about last time, we built this thing from negative 2 pi to 2 pi. We built our graph and we started talking about what the values were at 0 pi and pi over 2 and pi and so forth.
2 pi.
And 2 pi. So let's do the same thing with tangent, and we did some negatives. So I tell you what I'm going to do. I'll use black. What color you want to choose?
I was going to use black because black is beautiful. I guess I'll use blue.
Blue is beautiful as well. All right. So today, guys, we're graphing y equals. I don't know if I want to put it right there. It might run into our. Oh, excuse me. Oh, I'm using the wrong one. All right. Let's put it. Today we're graphing y equals 10. I'm going to put it right here at the top. Y equals tan x or theta, either way, doesn't matter. X-axis, and of course this is our y-axis. All right, at 0 pi, Mr. Simmons,
Yes, sir.
we have to divide the y, which is 0.
Tangent is sine over cosine.
There you go, sine over cosine, y over x. And so we divide 0 by 1, and what do we get?
Dividing 0 by 1 gives you 0.
0.
You can divide anything into 0 and get 0.
All right, I'm going to go ahead and set this up as 2 pi over 2 and 3 pi over 2. And we said we're 0 at 0 pi or the origin. And Mr. Simmons is finishing up our scaling by pi's over 2's. And let's go ahead and put us a 1 and a negative 1 on our y-axis. So what about pi over 2, Mr. Simmons? If we go up to pi over 2, the ordered pair.
Where we're at 90 degrees, we're at 0, 1. And if if tangent is sine over cosine, y over x, that seems like that'd make a really good true or false question on a test.
Yes, it would.
1 over 0. Now, if you were in my classroom, at this point, you would push the button. And all of my students know what the button is. It creates a huge, gigantic explosion because we are not allowed to divide by 0. It's an undefined function.
Now let's see, graphically, undefined leads us to the idea of an asymptote, right?
Yes, it does.
So there's a vertical asymptote at pi over 2. So I'm going to try to draw this appropriately. You guys are going to have to draw this as well. Vertical asymptote x at pi over 2. Okay, so then we go to pi.
We can go all the way around? Okay, pi.
And if we go to pi, where is that?
We're at negative 1, 0.
Negative 1, 0.
But I'm still dividing by 0. So I've got another 0.
Ah, we're still dividing by 0. So we got another 0. Huh. Or dividing by 1. You were right. It's 0, Mr. Simmons. So it's
Sine over cosine y over x.
So it's 0.
I said the right thing. I wrote the wrong thing.
All right.
0 over negative 1 gives us 0.
Okay, great. Now let's go to 3 pi over 2, Mr. Simmons. What do we have at 3 pi over 2?
We're at 3 pi over 2, or 270 degrees. I've got 0, negative 1, y over x, sine over cosine. And I've got an undefined function again.
And when it's undefined algebraically, graphically, we have an asymptote on our graph. All right, now if you'll notice, we have a 0 x-intercept. At pi over 2, we have an asymptote, vertical. At pi, we have another 0 x-intercept. And at 3 pi over 2, we have an asymptote, correct?
Looks like bad wallpaper.
Yeah. Absolutely. So it appears is that every pi over 2, something important is going on.
Yeah.
So I'm going to guess that something probably important is going if we back up a pi over 2. At negative pi over 2, puts us back over that undefined, right?
Right.
So I bet there's an asymptote. That's terrible. Mr. Simmons, why did you let me draw one that bad? Oh,
You are
I
a
can't
free
do
moral
that.
agent, Mr. Macklemore. I'm not responsible for your actions.
okay, so tell you what I'm gonna do, guys. I'm gonna draw it this way to try to make it nicer. Alright, so what I really want to do, we can come out and work with this, but I really want to work in this area negative pi over 2 to the pi over 2. That is going to give us one period in tangent.
Yes, sir. Yes, it is.
And we'll come back to that in a second. So if you'll notice though, before we had 5 key points. We had a start, a stop, a middle, and then like a quarter of the way and 3/4 of the way. So if we use that logic here, we have a start is an asymptote for tan. We have a stop is a vertical asymptote for tan. And we have our middle point.
But that really doesn't give me an idea at all of what the shape of the graph is going to be
It's
like.
just a point and some asymptotes.
Yeah. So maybe we could have some extra points.
Yeah, what about that quarter of the way point, the half of the half, and the 3/4 way point?
That would be pi over 4.
Pi over 4.
And at pi over 4, I've got root 2 over 2, root 2 over 2 for cosine and sine. If I sine over cosine, if I want to find the value for tangent, I'm putting the same value over itself, and I get
1.
positive 1.
So I'm going to go up here, guys. I'm going to estimate. Remember, pi over 4 is halfway between 0 and pi over 2. I'm going to go up and put a point right there.
Okay.
And so let's back up here. This would be negative pi over
So it's just
4.
45 degrees clockwise, right there. And here I've got root 2 over 2, negative root 2 over 2. So I'm putting the same value over itself. One's negative, one's positive. That's going to give me a negative 1.
So I'm going to put a point right there. I think we can start to see how this graph
Yeah, it's starting to take a little shape here.
take shape.
Yeah.
So what we have here, guys, and remember, as we draw, we always get close to our
Asymptote.
asymptotes. We approach it, but we do not touch or cross it. Now that's what tan is going to look like. Now if I wanted to draw another period, I could go halfway between pi and 3 pi over 2,
Mhm.
and that would put me in the third quadrant, which would be
Right.
5 pi over 4, and we could do the same thing. We could put a point at
At
1, and then at 3 pi over 4, which was halfway between pi over 2 and pi, that would be a negative 1,
Mhm.
because we're in the second quadrant, negative over positive. And so
Right there.
we also have, oh, that's terrible. I have to erase. I wish I had the back feature. This doggone dual user, it has its pluses and its minuses. So let's see if I can't do this.
Just like a number line.
Just like a number line. And that point, we'll just make it bigger so it goes through it. All right. So anyway, guys, I really am interested in this middle one. If we tell you guys to graph one tangent period, you can either graph here, or you can either graph here, or any of the other places. Just remember though, the period of tangent is not like sine and cosine. It's 2 pi. But the period of tangent from negative pi over 2 to pi over 2 is 1 pi. So
It's
this
pi.
is 1 period.
A half pi, a half pi, a whole pi.
Bam. Half and half is all every day. All right. So, Mr. Simmons, you ready to do a little
Cotan?
Cotan? I tell you what to do. Can you clear that sucker off? I can't clear it. Do it. Clear the annotation. All right. So now, guys, we're going to do y equals cotangent of x or theta. It doesn't matter how you guys look at it. I think our book uses x. Theta is definitely okay to use. It's an unknown angle. So I'm going to, again, go over here and put a 2 pi. And halfway in between 0 and 2 pi is pi. And halfway in between that is 3 pi over 2. And halfway in between 0 and pi is pi over 2. So, Mr. Simmons has our unit circled up there as a reference. And he is now scaling the axes by pi over 2.
It's a lot easier to scale an axis if it's horizontal instead of vertical, because you don't have to keep lifting yourself up.
I like that. So, that's pretty good.
Okay?
Okay, so again, let's look
Let's start
at
at 0.
0.
Okay.
And the ordered pair at 0 is 1, 0.
Now this is cotangent.
It's cotangent.
It's a little different than tangent.
It is. They're reciprocals, if I'm not mistaken.
So cotangent will be cosine over sine.
So that's x over y.
X over y. So my x is at 0 radians. X is 1, y is 0. I've got 1 over 0.
Undefined. So
So
guess
now-
what goes here, guys?
Vertical asymptote is on the y-axis. for
Interesting.
cosine.
Not at negative pi over 2, but the y-axis.
So already we see some differences.
What's at pi over 2?
Pi over 2, or 90 degrees. X over y, 0 over 1. That will be 0.
0, guys. 0. What about pi,
And
Mr.
at
Simmons?
pi, I'm at negative 1, 0. X over y, negative 1 over 0. Again, it'll be undefined.
So guys, we're going to try to put us a vertical asymptote here. And it's not beautiful, but you get the picture. So it's almost like tangent's kind of been shifted by pi over
Right.
2. I wonder if the graph of cotan looks like the graph of tan.
Okay?
Let's go these 1/4 and 3/4 points, half of a half. So let's go to pi over 4, Mr. Simmons.
And pi over 4, again, it's root 2 over 2, root 2 over 2. If I put cosine over sine, x over y, same value over itself, I get positive 1.
Ah. Okay, and what about 3 pi
3 pi.
over 4? That's halfway between pi over 2 and pi in the second quadrant.
Now here, the x-coordinate's negative. The y-coordinate is positive, still root 2 over 2.
But it's negative 1.
So that would give me a negative 1. A negative 1. I was off camera the whole time.
So interesting. I notice a little difference in cotan.
Yeah, not only is it
And tan.
shifted as you move left to right, cotangent is decreasing.
Ah, tangent was increasing. Now, we didn't really mention it there,
No.
on there, but if you remember,
As you move left to right.
tangent was increasing, moving left to right. But cotan is decreasing. So the main difference in tangent and cotangent, if we go back, just a quick review on tangent. Tangent is negative pi over 2, we have a vertical asymptote, and pi over 2, and it's increasing. And cotangent has a vertical asymptote at 0 and pi, and it's decreasing. Now I wonder what the period, if the period of tangent was pi, I wonder what the period of cotangent is.
Well, it's starting at 0, and we end at pi, and 0 to pi is still
It's
pi.
pi.
So they have the same period, even though the parent graphs have different starting locations, if you will.
Yeah, sure. All right, so today we've done parent graphs of tangent and cotangent. Make sure you know what the asymptotes are. Make sure you know if they're increasing or decreasing. Make sure you know what the period is, and make sure you know these
3
points. Need 3 points in between that to draw
Asymptotes.
us. That's right, in between
That's right.
asymptotes to draw a smooth curve. See you next time.
All right.
We're out of here.